In this video, we solve problem number 1 from the fall 2020 quiz number 5. It is a homogeneous linear ordinary differential equations with constant coefficients. So we have the fourth derivative of y minus 8 times the second derivative of y plus 16y equals 0. Since the differential equation has constant coefficients, we're going to start by letting y equal e to the mx. And then find the values of m that cause this function to satisfy that differential equation. Since it's a fourth order differential equation, we'll compute the first, second, third, and fourth derivatives of this function. The derivative of e to some power is e to that power times the derivative of the inside by the chain rule. So you end up multiplying by an m. Then you bring your m down, and then you multiply by e to the mx's derivative again. Derivative of e to some power is e to that power times the derivative of the inside, which gives us another m, so we'll have an m squared out front. Every time we take a derivative, we end up multiplying by another m because of the chain rule. And then we substitute these into the differential equation. So our differential equation was the fourth derivative of y. So in this case, if y is equal to e to the mx, the fourth derivative of y would be m to the fourth times e to the mx. And then we're subtracting 8 times the second derivative of y, assuming y equals e to the mx is a solution. The second derivative is m squared times e to the mx. And then we're adding 16 times y. And y was e to the mx. We set that equal to 0. And then we factor out the e to the mx. And we say to ourselves, actually, e to the mx is never 0. So the only way that is true is if this polynomial in m is equal to 0. So we substituted into the differential equation and simplified. And then we have a characteristic equation. This is an nth degree polynomial in m. And you just have to solve for the roots of that polynomial. Since it's a fourth degree polynomial in our case, we need 4 roots. I noticed right away that since I've got an m to the fourth here and an m squared here, and no m cubed term and no m term, that this is quadratic in form, so it can be solved by factoring in much the same way that we would solve or factor a quadratic polynomial. But instead of having an m and an m here, in order to get an m squared, or excuse me, and an m to the fourth, we're going to have an m squared here and an m squared here. First times first is m squared. And then outer times outer plus inner times inner has to be that negative 8m squared. And then last times last has to be 16. So we're looking for two numbers that multiply to give us 16 that add to negative 8. Negative 4 will work. And so now we've got this. And each of these is a difference of squares, so we can factor those to m plus 2 times m minus 2 and m plus 2 times m minus 2. And that means we've got m plus 2 squared times m minus 2 squared. So that is the factored form of our characteristic equation. Then you want to solve for m2, m3, or m1, m2, m3, and m4. Since this factor is repeated, it's squared, there are actually 2 values of m that come from this one. This product is 0 if this factor is 0, or this factor is 0. This factor is 0 when m is equal to negative 2. And since it's a repeated root, we can think of m1 and m2 both being equal to negative 2. And the same is true for this one. These guys are both equal to positive 2. And I'll think of those as my third and fourth roots of the polynomial equation. Now, since we have repeated roots, we get two solutions for each of those repeated roots. Because it's repeated twice, we get two solutions. Since m1 equals -2, y1 is e to the -2x. Y sub 2 is that times an extra x. Over here, we have y sub 3 equals e to the m3x. And y sub 4 is x times e to the m3x. So the general solution is y equals, well, since it's a fourth order differential equation, it's going to be c1 y1 plus c2 y2 plus c3 y3 plus c4 y4. And then our y1, y2, y3, and y4 are as stated above. So I'm just going to copy those down now. And these will work for all real numbers. So we use the m's to find the y's. Make sure you have 4 of them because it was a fourth order differential equation. And then we state the general solution on I, which comes from multiplying each of those functions by constants and adding them together to get the general solution.